Okay, in this lesson, we'll talk about the binomial theorem. This is review of last year, and let's remember what the symbol means. It's called this is 5 factorial. It means multiply all the numbers from 5 down, all the natural numbers from 5 down. So we get 120 here, 3 factorial, 3 times 2 times 1, and also 0 factorial equals 1, and that is that's what everybody agrees on. It doesn't really make sense, but that's the definition. Then we have 6 choose 3. This is also written 6 choose 3. We can write it like that or like this, and it means 6 factorial, 6 minus 3 factorial, 3 factorial. And then we expand everything, 6, 5, 4, 3, 2, 1. And this will be a 3. And this is a 3 factorial. Remember, we can't have 3 times 3 and have 9 factorial. We have to do 3 factorial separate from this 3 factorial. And then we just cancel as much as we can, and we get 20. 5 choose 2. 5 choose 2. Five factorial, 5 minus 2 factorial, 2 factorial. 3, 2, 1, 2, 1. So we can cancel all of that. And let's see the connection to Pascal's triangle. So in Pascal's triangle, we just start with a 1, and then we have a row of 1s. We start with 1, and then 1 plus 1 is 2, and we end with a 1. Start with a 1, 1 plus 2 is 3, 2 plus 1 is 3, end with a 1. 1 plus 3 is 4, etc. If we keep going, and then we can see that 10 appears here, and this is 5 choose 2. 5 choose 2 is 10. That appears right there. This is 5 choose 0. 5 choose 1. 5 choose 2. 5 choose 3. 5 choose 4. 5 choose 5. 20 appears down here, and that is 6 choose 3. So this is 6 choose 0, 1, 2, 3. That's 6 choose 3. We could also represent Pascal's triangle like this. 0 choose 0 is 1. 1 choose 0 is 1. And 1 choose 1 is 1. Then we'll have 2 choose 0 is 1. I'm sorry, 2 choose 0 is 1. 2 choose 1 is 2. 2 choose 2 is 1. And we could, all of these combinations represent each of the elements of Pascal's triangle. And we are reviewing all of this so that we can do binomial expansion. This is a binomial because it has two terms, and then we have it to raise it to a power. If it's only the second power, then we could just do this. And remember that we don't just get x squared and 9, we get x squared. 3x plus 3x is 6x plus 9. But what if we have x plus 3 to the 5th power? That would require writing out 5 factors and doing this 4 times. But instead of doing that, instead of writing all of these out and doing this repeatedly, we can just use the binomial theorem. And that would give us, instead of multiplying like this with distribution, we would have 5 choose 0, and then we'll have x to the 5th, 3 to the 0. And we're going to have 6 terms. So 5 choose 0, and then we'll go 5 choose 1, 5 choose 2, this is x3, 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 and if we start with a 5 as the exponent here, well, then we'll go 4, 3, 2, 1, 0. We can count the other way, 5, 4, 3, 2, 1, 0. Also, you can check to see that every time we have these exponents, they have to add up to the degree of the polynomial. 4 plus 1 is 5. And then remember that each of these, 5 choose 5, 5 choose 5, 5 choose 3, these are all the factorial formulas. All right. And if we have the third degree polynomial, we can we know that we have to have we keep going until we get to a 3. And maybe it's hard to remember how many rows we need in Pascal's triangle, but it's going to be one more than that degree, and we're going to see that degree show up right here. Okay, and if it's a third degree, we'll have 4 terms. So I think it's helpful just to write everything out like this. And for A, and negative B, remember that NCR is the same. We can also write it like this, so that's just less writing. And now we can write it as, oh, we're not doing that yet. Because we're using Pascal's triangle, we're just going to use the numbers here. 1, 3, 3, 1. 1, 3, 3, 1. And then we need to start with 3 and count down. Start with 3 here. 2, 1, 0. Then we can just expand everything. So we have 1, this would be 4 to the third power. That's 64, a cubed. This is 1, so it's times 1 there. Here we're going to have 3 times 16a squared times negative b. 3 times 4, that'll be a 12a times b squared. And here we have a 1 times 1, and that'll be negative b cubed. Minus negative 48 a squared b Alright, pause the video and try that one. We have to go until we get to the 5, 10, 10, 5, 1. Those are the coefficients that we're going to use. And then let's put out the spacing. We need 6 terms. And we know the coefficients, 1, 5. And then we have m, negative a. We'll start at 5 here. 5, 4, 3, 2, 1, 0. 5, 4, 3, 2, 1, 0. And now we just expand everything. That'll be m to the 5th, and that's a 1 times 1, so we get m to the 5th. Here is negative 5m to the 4th a. Negative 5m to the 4th a. And this is 10m cubed a squared. Here we have 10m squared, and that'll be a negative 10m squared a cubed. Here is a 5m a to the 4th. 1 times negative a to the 5th. Ooh, almost made a mistake there. Well, I did make a mistake, and that should be a 2. Every term should have a degree of 5, so this is 5. This is 5 plus 4 plus 1 is 5. 2 plus 3 is 5. 2 plus 3 is 5. 4 plus 1 is 5, and there's a 5. So when we have higher degrees, we don't want to use Pascal's triangle because it would be too big. So now we can just focus on finding the sixth term. We don't have to find the whole polynomial. We just have to go as far as we need to go to find out what the sixth term is. So if we have the 12th degree, we'll have 13 terms. 1, 2, 3, 4, 5, 6. It goes on. 7, 8, 9, 10, 11, 12, 13. So if we were doing the whole polynomial, we would have to do all that work, but all we have to do is find the sixth term. 1, 2, 3, 4, 5, 6. We know we're dealing with. That's the only one that we need. And if we just start filling in the numbers, we'll keep going until we know everything that's in here. So let's start with, this will be 2c, 2c. We know all of the middle factors are 2c, and then we have negative d there. What are the exponents? Well, we're going to start with 12, 12, 11, 10, 9, 8, 7. We could count from 0, but also we know that 7 plus this number has to be 12, so we know that's a 5. And then we'll have 12 choose 0. It doesn't matter if you start with 12 choose 0 or 12 choose 12. Because of the symmetry of Pascal's triangle, when you look at Pascal's triangle, if you say, here we have 1, 2, 3, 4, this is 4 choose 0 and 4 choose 4, 4 choose 1, and 4 choose 3. They're the same. So due to the symmetry, it doesn't matter if you start with 12 choose 0 or 12 choose 12. Alright, so that's 12 choose 0, 1, 2, 3, 4, 5. 12 choose 5. And then we just have to expand all of this. Let's do 12 choose 5. And then we'll have, in the denominator, it's 12, numerator is 12 factorial, 12 minus 5 factorial, and 5 factorial, 7 factorial, 5 factorial, and we know that all of that cancels. And then we could look for 3 and 4 is 12, 5 and 2 is 10, and then we get 5, 4, 3, 2. Alright, and now we have, I'll just write it as 99 times 8. This gives us 99 times 8, and that's 12 choose 5. Then we have 2 to the 7th, c to the 7th from there. We'll put the negative in front, and then d to the 5th. If we multiply all of this, we'll have negative 101, 376, c to the 7th, d to the 5th. And it did only ask for the coefficient, so we would say that that is the answer to the question. That is the coefficient. If it asked for the sixth term, the sixth term is the whole thing. The coefficient is just that number. Remember that sometimes people say, oh, the coefficient is just going to be the element of Pascal's triangle, but then when we have coefficients inside each of the terms here, these contribute to the coefficient of the final term. So again, it's asking for a specific term. Just start representing the whole polynomial and then go as far as you need to go to get the term that has x to the 6th y cubed. Pause the video and try that one. 9th degree, so we know that we would have 10 terms. And it goes on until we get to 10. Let's see if we're going to have the x to the 6th within these. And we have 6, 9, 8, 7, 6. So that's the term we're going to need. And 2x goes here. 2x. 3y. The sum of the exponents is 9, so we know that's a 3. And we can have 9 choose 0, 9 choose 1, 2, 9 choose 3. Then we just have to expand that. Six. And 3 factorial. So let's cancel the 6 factorial, and we can have a 3 canceling part of the 9 and a 2 reducing the 8. So that gives us 12 times 7 is 84. There, that gives us 84. Then we have 2 to the 6th, x to the 6th, 3 to the 3rd, y to the 3rd, and if we multiply all of the numbers, we have 145,152. It asked for the coefficient, so we identify the coefficient. So here's saying find the term, and we have to be careful because since there's an x in the denominator, then this is going to be reducing the degree of each of the terms. So just start expanding this and pause the video to try that one. It's 10th degree, so we know we would have 11 terms. Hopefully we don't have to do too many of these. Let's just start with a few and see if we reach our goal. One over x. 3x. And then we'll have 10, 9, 8, 7, 6, 5, 4. 10, this will be 0, 1, 2, 3, 4, 5, 6. We need the term that ends up with an overall degree of 4. Quartic means fourth degree. So we have a x to the 9 in the denominator and x to the 1 in the numerator. This would be x to the negative 8. So this would have an x to the 8 in the denominator. Here we have x to the 5th in the denominator, x to the 5th in the numerator, and that means that would be a constant term. There'd be no variable there. And we want a fourth degree, so it looks like we're going to keep going. We have here a second degree because x to the 4th is in the denominator, x to the 6th is in the numerator. Four, 3, and then 6. This will be a 7. Now we have x cubed in the denominator, x to the 7th in the numerator, so that's going to make an x to the 4th term, and that's the one that we want. And we're going to start with 10, choose 0, 1, 2, 3, 4, 5, 6, 10, choose 7. And that's 10 minus 7, 3 factorial, and then 7 factorial. Seven factorial cancels the 7 factorial. 3 reduces the 9. 2 reduces the 8. So we'll have 120. This is 1 over x cubed. And then 7 to the 3rd power. 3 to the 7th power. X to the 7th. And it did ask for the whole term, not just the coefficient. So we'll make sure that the variable is included in the answer. And that's the end of this lesson.